So welcome to this discussion as we continue looking at the 2024 5070 paper 2 A7 there. It says a solution of copper 2 sulfate in water contains the following ions. So copper 2 ions, hydrogen ion, sulfate and hydroxide. Then it says if an aqueous solution of copper 2 sulfate is electrolyzed using innate electrodes, what product is formed? So remember, innate electrodes are electrodes like carbon, graphite if you want. You can also talk about platinum. So these are innate electrodes. They have got no effect on the preferential discharge in this case. So you just follow the order of the electrochemical series. So what product will be formed at the anode? Remember, the anode is positive. Now, because the anode is positive, it simply means the sulfate and the hydroxide are going to be discharged at the anode. But which of them will be deposited? Well, the hydroxide are going to be deposited. Why? Because they are lower in the electrochemical series. So what product is formed at the anode in this case? That's what the question is actually telling us. So it simply means that you are going to have, oxygen gas. So the reason why we are saying oxygen gas, because hydroxide ions produce oxygen and H2O, and if you balance up that, that, you are going to find, no, that's a 2. So if you balance up that, you are going to see that's 2 plus 2, so we don't have there, so plus 4 electrons. So you can see that oxygen will be produced. So oxygen gas is actually expected to be produced at the anode. Then at the cathode, you expect to have copper metal is actually going to be deposited. So the copper 2 ions will gain 2 electrons and hence they will become copper. So that's what they wanted you to write there. Then it says write a chemical equation for the reaction that would occur between magnesium metal and the solution that remains after electrolysis, includes state symbols. Now remember, since copper has been eliminated, the hydroxide has been eliminated, what will remain are hydrogen ions and, in this case, sulfate ions. So when these combine, it simply means that they are going to produce sulfuric water. They're going to produce sulfuric acid. So when they produce sulfuric acid, it simply means magnesium, which is in solid, it's a metal, will react with sulfuric acid. Sulfuric acid is in aqueous form. When the two react, a metal and an acid, it will produce a salt, magnesium sulfate, which is still in aqueous, plus hydrogen, which is a gas. Is this equation balanced? Yes, the answer is that it is actually self-balanced. So that's what they wanted you to do there. Then look at our concluding part for this question C. It says, draw a well-labeled diagram of the experimental arrangement that can be used to electroplate an iron spoon with silver metal. So since this is electroplating, remember what you want to electroplate, it's supposed to be on the cathode. In this case, our spoon, which we want to electroplate, is going to be on the cathode. Then the metal that we are using to electroplate, the metal that we are using to electroplate, since we are using silver metal, the silver metal is going to be on the anode. Then the other thing that you need to focus on is simply the electrolyte. So the electrolyte should be an aqueous solution of the metal that you are using to electroplate on the spoon. So you can simply get silver nitrate. So you can use silver nitrate in this case. So that's what you just needed to do. So you could have used silver nitrate in that. So you just need to draw this arrangement, and that was actually carrying 4 marks. For example, if I say that's my current, this is negative and this is what positive, it simply means that towards the cathode, this is where I'm actually going to have my spoon here. Then this side, I'm actually going to put up a metal that we want to electroplate. So all these are going to be in the electrolyte cell in a solution form, and that solution that you are going to have there. So this is a silver metal, so you label that nicely. This is actually your spoon, and that is representing the cathode, and this one here is actually representing here, that is the anode. Then the solution in there is supposed to be silver nitrate. So this is what you can use to electroplate. So this is what I wanted you to do in this question. Please watch out as we look at our last question for section A before we start looking at section B. We'll come and do this question there, in my next video. Thank you so much for watching. If you love what we do, please subscribe to my channel.